Hello folks, in the last video we talked about various kind of database services that are provided by AWS. So we've seen RDS, which is a relational database service. This is for SQL type of databases. We have seen DynamoDB, which is NoSQL database. We got to know about Elasticsearch, which is in-memory data store. And then we talked about Redshift, which is basically a data warehousing solution. Now here in this video, we are going to talk about relational database service in general and MySQL RDS in particular. So let's start with talking about the features of RDS, the kind of service AWS provides, and then we'll go on and create an RDS instance with MySQL DB engine, and we'll connect to it using one of our EC2 instance. Okay, so as we talked about RDS instance in the last video, AWS is basically providing us a platform which we can use and start creating our databases, start putting data into the database without being bothered about the underlying infrastructure. So basically RDS is a platform as a service, not an infrastructure as a service. So having said that, if you have to create, say, a database on the cloud, there are two approaches. First approach is you can create an EC2 instance and then you can install your DB engine, etc., whatever you want. This is the traditional way, like how you do on your on-premise servers. The second and better approach is that you use RDS service, which is basically a platform as a service. You get a range of database engines like Oracle, MySQL, Postgres, MariaDB, etc. And you can use just that platform that you are getting. So there would be a lot of features already in place. For example, taking the snapshot of your database, restoring your database to a time which is already passed, monitoring your databases in a visual format. So a lot of features are there, which we'll explore in a while. You don't have to basically go and run commands on your databases to understand what is going on there. A lot of monitoring is already in place. If you want operating system level of privileges, then go for EC2 instance and install a MySQL. If you are just want to start a database, create a database from scratch, and then you don't have much of the IT staff to manage the databases, then a lot of features of the RDS itself you can use. You don't need much of DBA guys to monitor your database. So let's start with looking at our RDS dashboard. Just log into aws.amazon.com, and there in the database services you click on the RDS. So if you have got a fresh account, you will get this get started page. So as AWS describes it, RDS is easy to set up, operate, and scale relational databases in the cloud. Let me remind you once again that this is for relational databases, which means SQL type of databases, which has got a fixed schema and where you can run SQL type of queries. For non-relational or NoSQL database, you have to go to the DynamoDB. Okay, so let's get started here. Click on get started now, and there would be steps to follow to create a particular RDS instance. The first step itself asks you what kind of database engine you are going to use. You can go for Amazon Aurora, which is a relational database created by AWS itself. They are giving you a lot of features on Amazon Aurora. You can go down here and read out all the features that they have. So it gives you 5 times the throughput of MySQL and 3 times the throughput of PostgreSQL. You can create a single database having 64 TB of SSD storage, 6-way replication across availability zones. So it's very much disaster proof. You have up to 15 RAID replicas. So you can create 15 copies of this database, which will allow read-only connections. That is what we mean by read replicas. Now Amazon Aurora, they have made compatible with MySQL as well as Postgres compatible. So here you see, if you select Amazon Aurora, you can get it MySQL 5.6 compatible, 5.7 compatible, and PostgreSQL compatible. So from here itself, you have to first select that what kind of compatibility you want. Now, having said that, you have got all the traditional database, most of the open source SQL type databases that you get, you can find it here. So you've got MySQL, MariaDB, Postgres, Oracle, and then multiple editions of the Oracle. You got Enterprise Edition, Standard Edition 1, 2, all these various editions you can get. Same thing about Microsoft SQL Server. If you want to go for MS SQL, then you can see various kind of editions are already available. You can select any of these and go ahead. So if you're creating a RDS instance by yourself for the first time, it would be important for you to understand the features that each of these RDS DB engines are providing. So you should ideally go and read about features and compare them with each other. Now I'm going ahead with MySQL database instance. So some of the features and limits are explained here itself. So this supports database size up to 16 terabyte, and I'm talking about single SQL database. You can get instances up to 64 virtual CPU in fact, and 488 GB of memory. RDS instance, and especially MySQL RDS, supports automated backups. You can create manual snapshot, and you can create multiple RAID replicas, up to 5 RAID replica in fact, and these RAID replicas can be across the region in a separate region as well. So just select MySQL and go to the next. Now here in the second step, it asks for what kind of use case you are going to use. So when you are working with enterprises, you would be normally going with the production use case. Again, depends for what you are going to create this RDS. Now if you are going for production, then AWS again suggests that use the Amazon Aurora because it has got a lot of features and relatively low cost. So you can go for production MySQL as well, which is giving you some extra features like multi-AZ deployment. That means if you want to create an standby instance as well, so that in case of a disaster or in case of a failover, the control goes to the standby instance as well, then you need to use multi-AZ deployment. So the other standby instance gets created in another availability zone itself. So even if the whole data center goes down because of some disaster or something, then you can move to the other standby instance, and this whole process of failover handling will be done by AWS itself. You don't have to do anything. You need to just add this multi-AZ feature, which is available in production MySQL, not in the dev test MySQL. Another feature for production use case is provisioned IOPS. Remember we talked about EBS volumes in last section where we talked about EC2 instance and related volumes. So similarly here also the storage which you are getting, you can go for general purpose SSD storage or for provisioned IOPS storage. Now for production kind of use cases, you would normally go for provisioned IOPS because it will give you a very high IOPS, that is input output per second, so you can get very high performance with this storage. Now I'm going to use the dev test MySQL. Now having said that, I can still use multi-AZ feature and provisioned IOPS even with my dev test MySQL. If you are using free tier and if you don't want to get charged, then use dev test MySQL only. So just select the dev test MySQL and go to the next. Now at this page, we are going to give some more configurations. So the DB engine we have already selected, which is MySQL Community Edition. You can select the license model, which is only one here, and then you can go and select the DB engine. So here you can see that these are the various MySQL editions that are supported here. You can select whatever you want. I'm going ahead with the default one, which is 5.6.39. So for now, issues and limitations are documented properly by AWS, and you can just go and see this page. Then for free tier use case, if you don't want to get charged, you can just select this option here and it will select only the free tier compatible versions here. If you want to explore all the options, just uncheck this box. Now I hope you do understand that when you are creating a database server, it is ultimately going to use some EC2 unit, right? It's going to use some compute unit, and that compute unit would need some CPU, some RAM, and you can get a range of compute units out there. So to select that, you have got this DB instance class. So it is similar to our EC2 instance type, except it is about the database. So you can see here db.t2.micro, which is giving you 1 virtual CPU and 1 GB of RAM. You can go on and select very high capacity compute units. So for example, you've got this R4.16x large, which is providing you 64 virtual CPU and 488 GB of RAM. So of course, the pricing of the database will differ based on what kind of RDS instance you are choosing. So I'm going ahead with T2.micro only. Now, as I said that multi-AZ deployment is not there in the free tier, but here you can select it. The only problem would be you will be charged accordingly. So if you want to create a similar replica in a different availability zone, or you want to have that failover mechanism inbuilt in your RDS instance, then you have to select this multi-AZ deployment. Right now, I'm not going to select that. Then your storage type. Now, if you're using it for dev test purpose, general purpose is okay. But if you're going to use it in production, then you should go and select a proper provisioned IOPS SSD storage, which gives you very good performance. So if you're using provisioned IOPS storage, the minimum volume you can use is 100 GB, and you can also define that how much IOPS do you want. If you are going to use general purpose, then the minimum database size is 20 GB, and of course you cannot provision your IOPS. Now in the next block of setting, you have to give the name of the database server or the database instance. So here we have to write a name. So let me call it my DB instance. Remember, we are giving here the name of the database instance, not exactly the database. In one database instance or in one database server, you can have multiple databases. So here we are giving the name to the database server, not exactly the database. Then to connect to this database server, we would need a master username and password. So from here you can configure that. I'm going to give it Ashish, and a password I am going to set. Remember, you have to give a strong password, otherwise it will fail. It won't show it here, but later on it will give you an error. So once I have set the username, password, and the name of the DB instance, I can go to the next page. Now, as part of advanced setting, we have to select the criteria like in what network I'm going to create this. If you are going to make a RDS secure, then you should have your own VPC and create this RDS within that VPC, within your own virtual network. But you can also create it within your default VPC, which is provided by AWS. So you see here, I have got multiple VPCs of my own, but I'm going to use default VPC for this demo. So by stating this VPC and the subnet group, you are exactly telling that in which data center, in which region you are going to create the RDS. Then I'm using the default subnet group. Subnet groups are provided default as well, which will include a group of subnets within the default VPC. If you are using your own VPC, then you should create your own subnet, which basically tells that what are the subnet in which database instance or a replica of it can be created. In the next setting, we need to tell that what kind of database I'm creating. Will it be publicly accessible, or is it an internal database server? So if it is an internal database server, then that database server can be connected only from within the virtual network, only from within your own VPC. If you are creating a publicly accessible database, then it can be connected from anywhere through the internet. So basically, if you provide a public accessibility, then a public IP would be chosen and the DNS name of the RDS will resolve to that public IP. So I'm selecting this public accessibility here. Having said that, most of the time you will create your database server as an internal server so that it can be connected only from your own internal network. But since we want to connect to this database from another EC2 instance, so we are going to give it public accessibility. Then we can select the availability zone or the exact data center where we are going to create it. So in Mumbai region, you have got 2 availability zones. You can select any of these. And then similar to what we created for EC2, we can create a security group here as well. And we can define that what kind of traffic would be able to access this database server, on which protocol, on which port, and from which source we are going to allow traffic to this database server. So that is managed by your security group. So I'm going ahead and letting it create a security group for me. Now this is where I give the name of my primary database. Now this is optional. I can create database later as well. But when I give it a name here, it is going to create a default database in the database server. So now here, I'm going to give it a name, demo DB, and since MySQL by default works on port number 3306, so I'm going to keep it the default. Now my MySQL DB engine can be tweaked by setting various kind of parameters. These parameters are grouped together in a parameter group. So this is a default parameter group that AWS provides, but you can create your own parameter group and you can change the various parameters which are related to the internal working of your SQL engine. So I'm going ahead with the default parameter group and similarly default option group. Now you understand that in a database, you create multiple users. And you have also seen that you can create multiple IAM users. So if you want to control your database users by using IAM user authentication, then you can enable this IAMDB authentication. So for now, I'm going to keep it simple and I'm going to disable it, but keep it in mind that you can control your DB users by using IAM user as well. Then you can enable encryption of your data which is on the database, but this particular instance class that we are using, basically the t2.micro, on this one we cannot use encryptions. Based on your instance class and the kind of database engine you are using, in some of the instance class and some of the DB engines, it may not be available. So we are going ahead without encryption. And here in this part, you can define that for how long you want to keep the backup. Now remember, in the feature of RDS, we talked about that RDS provides you point-in-time recovery, which means if you want to go a few days back and you want to restore your database to the stage on which it was there, say 5 days back, then you can do it. But for that, you need to have the automated backups. So this automated backup feature is on by default, but you can control that for how long you want to keep the backup. So you can keep the backup from starting from 0 days to up to 35 days. This is what it is available now. It may change in the future. And then of course, if you are taking a backup, you should do it when there is less load on your database. So you can define that at what time you want to allow AWS to take the backup. So you can select a window. It will be an indication to AWS that at what time it should take the backup. So we have discussed that there is a service called CloudWatch, which monitors all your AWS resources. But there are two types of monitoring. One is normal monitoring and then another is enhanced monitoring. The difference being just that how frequently CloudWatch service is monitoring your resource. So if you enable enhanced monitoring, you can specify the granularity with what frequency it should monitor your resource, your database server. So if you disable enhanced monitoring, then it's just that the frequency of the monitoring would be less. Now you can collect multiple type of logs that gets generated. You've got option of collecting audit logs, error logs, general log, or slow query logs. Whatever you need, you just select the box. Now, since AWS is providing you the hardware as well as the database engine, so there is a possibility of having a minor version upgrade, or they may apply some patches. So for that, there would be a maintenance. And again, like backup, you can select that in what window you want to have the maintenance done. So you can select window here, or you can just go for no preference. Once it is done, now I can click on launch DB instance and it will create the database server and we'll be able to see the details of that. So just click on launch DB instance and wait for a few minutes. It will take some time to launch the database instance, and then you will be able to see various properties of the database server. You can go here, view DB instance detail. Now you are in the instances tab, and here you can see various properties of it. Now you can see the DB instance status is just creating. It is using MySQL engine with version 5.6.39. Instance class is db.t2.micro. So it is not ready yet. If it gets ready, you will get here available. Now, as we talked about monitoring, so CloudWatch is the web service which is responsible for monitoring this database. It tracks various metrics here and it can show it here in form of chart and graphs. So you can see here, it's a very detailed monitoring basically. You can get here 10 pages of just monitoring. It is tracking 58 metrics of the database, which includes database connection, free storage space, read and write IOPS, and so many other metrics. Now, since my database is just starting up, so we are not getting here endpoint yet, but once it gets created, we will get a string. Using this string, using this endpoint, we will be able to connect to this particular database server. Other properties of the database server you can find from here in the details page. So this is how you basically create a RDS instance. In the next video, we are going to see that how to connect to this RDS instance and explore the RDS dashboard. So see you soon in the next video. Thank you for watching.